Alright, you are welcome again. We are still treating complex numbers. Today, let's take this question. Given that z1 equal to 2 root 3 minus 2i, z2 equal to minus 1 plus root 3i. Obtain the polar representation of z1 and z2 and find z1 times z2 and z1 all over z2 in polar form. Okay, so we have z1 equal to 2 root 3 minus 2i, then z2 equal to minus 1 plus root 3i. So we are asked to obtain the polar representation of z1 and z2, also to find z1 times z2 in polar form and z1 all over z2 in polar form also. Okay, now let's go. We have z1 equal to 2 root 3 minus 2i, and then we know our polar representation to be z equal to r upper bracket cos theta plus I sine theta. Now let's go. We have a need for r and then also the need for theta. So let's find our r in z1. So r is equal to square root of, we're going to have 2 root 3 in bracket squared plus minus 2 in bracket squared. So 2 root 3 squared is going to give us 12, and then minus 2 squared is going to give us 4. So we're going to have r is equal to square root of 12 plus 4. So 12 plus 4 is equal to 16. So we have square root of 16 is 4. So therefore our r in z1 is equal to 4. Also, let's obtain our theta. Let's find our theta. So our theta is going to give us tan inverse of minus 2 all over 2 root 3. It's going to give us tan inverse of minus 2 all over 2 root 3. So tan inverse of minus 2 all over 2 root 3 is going to give us minus 30 degrees. And then you discover that minus 30 degrees is a negative angle. So for us to obtain a correct corresponding angle, we're going to add 360. So minus 30 degrees plus 360 degrees is going to give us 330 degrees. Okay, we're going to have 330 degrees. All right, now here, let's change this 330 degrees to radian. Let's change it to radian. You know, in one of our tutorials or lessons, we have treated how to do so. Okay, please, if you forgot them, please, I will refer you to them. All right, now here, let's just divide both sides by 180. Okay, so when you say 330 divided by 180, you're going to have 11 all over 6. Okay, so we'll just say 11 all over 6 pi. All right, so our theta in z1 is equal to 11 pi all over 6, or 11 all over 6 pi. All right, now let's go. To represent this in polar form, that is z1 in polar form, so you know we have our polar form z equal to r upper bracket cos theta plus I sine theta. Now here we have found our r to be 4, we have found our theta to be 11 all over 6 pi. All right, now let's go. We're going to have z1 is equal to, in place of r we have 4. We're going to write 4 upper bracket cos our theta now is 11 all over 6 pi. We're going to have 11 all over 6 pi plus I sine 11 all over 6 pi. All right, good. So this is the polar representation of z1. All right, so we have z1 is equal to 4 open bracket cos 11 all over 6 pi plus I sine 11 all over 6 pi. Okay, now let's go z2. So we have z2 to be minus 1 plus root 3i. Let's also represent this in polar form. That means we're going to find our r and then theta. So let's find our r. R is equal to square root of minus 1 in bracket squared plus root 3 in bracket squared. Okay, so minus 1 squared is 1, and then root 3 squared is 3. So we're going to have 1 plus 3 is equal to 4. So we're going to have square root of 4. So square root of 4 is equal to 2. So our r in z2 is equal to 2. Let's find our theta. So we're going to have theta is equal to tan inverse of root 3 all over minus 1. So when you punch in your calculator, tan inverse of root 3 all over minus 1, we're going to obtain minus 60 degrees. So plus 180, because it do not correspond. This is a negative angle. So for us to have a positive angle, we're going to say plus 180 degrees. Okay, so minus 60 degrees plus 180 degrees, we're going to have 120 degrees. So let's also change this to radian. When we change this to radian, we're going to have 2 all over 3 pi. 2 all over 3 pi. Okay, so we have found our r to be 2, and then our theta to be 2 all over 3 pi. So let's represent this in our polar form, and then we're going to have z2 equal to, our r is to have 2 open bracket cos 2 all over 3 pi in bracket plus I sine 2 all over 3 pi in bracket. Okay, this is our polar representation of z2. We have z2 is equal to 2 open bracket cos 2 all over 3 pi in bracket plus I sine 2 all over 3 pi. Okay, now let's go. Number 3, we have z1 times z2 in polar form. z1 times z2 in polar form. And then you discover that in one of our lessons we treated a theorem. Okay, so in that theorem we say that z1 times z2 in polar form is going to give us r1 times r2 open bracket cos theta 1 plus theta 2 close bracket plus sine theta 1 plus theta 2. Okay, so you know our r2 is the r in z2. Okay, and then we have theta 1 to be the theta in z1, and then theta 2 to be the theta in z2. Okay, now let's go. You know, all these values we have solved for them above. We have solved them above. All right, now let's go. We're going to have z1 times z2 equal to our r1. We have 4 times r2 times 2 open bracket cos our theta 1, we have 11 all over 6 pi plus theta 2 2 all over 3 pi close bracket plus I sine theta 1 11 all over 6 pi plus theta 2 2 all over 3 pi. Okay, now let's go. 4 times 2 is going to give us 8, and then 11 all over 6 pi plus 2 all over 3 pi is going to give us 5 pi all over 2, or 5 all over 2 pi. All right, good, plus I sine 5 all over 2 pi. Is that clear? Yes. So when you say 11 all over 6 pi plus 2 all over 3 pi, it's going to give us 5 all over 2 pi. Is that clear? Good. Now let's go. Here we have 8 open bracket cos 5 all over 2 pi plus I sine 5 all over 2 pi. So when you say cos 5 all over 2 pi, it's going to give us 0. And then when you say sine 5 all over 2 pi, it's going to give us 1. Okay, yes, it's going to give us 1. So here we're going to have 8 open bracket 0 plus I open bracket 1. Okay, so let's use this 8 and open bracket. 8 times 0 0. Okay, so in the brackets we have I times 1 going to give us I. So 8 times I is going to give us 8I. So 8I plus 0 is equal to 8I. So therefore z1 times z2 in polar form is equal to 8I. Okay, now let's go. z1 all over z2 in polar form. z1 all over z2 in polar form. So also in our theorem we say that z1 all over z2 in polar form is going to give us r1 all over r2 open bracket cos theta 1 minus theta 2 plus I sine theta 1 minus theta 2. Hello, now let's go. We have z1 all over z2 equal to our r1 is 4 all over r2 is 2 open bracket cos our theta 1 is 11 all over 6 pi minus theta 2, we have 2 all over 3 pi close bracket plus I sine at theta 1, 11 all over 6 pi minus theta 2, we have 2 all over 3 pi. Okay, so when in this place now, we're going to say 4 divided by 2. 4 divided by 2 is going to give us 2. And then 11 all over 6 pi minus 2 all over 3 pi is going to give us 7 all over 6 pi. Okay, it's going to give us what? 7 all over 6 pi. Now let's go. We're going to have 2 open bracket cos 7 all over 6 pi bracket plus I sine 7 all over 6 pi. Okay, now let's go. When you punch in your calculator cos 7 all over 6 pi is going to give us minus root 3 all over 2. Then we have plus, we have I. When you say sine 7 all over 6 pi is going to give us minus 1 all over 2. Okay, so we have in the bracket 2 open bracket minus root 3 all over 2 plus I open bracket minus 1 all over 2. Okay, now let's use these 2 to put this bracket. So we're going to say 2 times minus root 3 all over 2 is going to give us minus root 3. Okay, good. Now when you say I times minus 1 all over 2 is going to give us minus 1 all over 2I, and then this minus 1 all over 2I times 2 is going to give us minus I. Hello, so Z1 all over Z2 in polar form is going to give us minus root 3 minus I. Is that clear? Yes. Thank you very much for watching. Please, if you are new to our channel, please do us a favor and just click the subscribe button, and also remember to turn on the notification. Okay, see you next time.